In this video, we're going to start chapter 12-4 and we're going to learn how to solve a matrix equation that involves matrix multiplication. So go ahead and pause the video and take your notes. Equations solving matrix multiplication are a little bit different to solve than equations that just involve adding, subtracting, and scalar multiplication. The first thing you need to do is you need to isolate the equation that has your matrix multiplication and your unknown matrix. So in this case, there's nothing else on this side with our matrix and our unknown matrix. So we can continue. The next step is to find the inverse of this matrix. If you can remember from 12-3, when you multiply a matrix by its inverse, you get the identity matrix. And any identity matrix multiplied by another matrix, you get just this matrix. So by multiplying by the inverse matrix, you effectively are dividing this matrix out. So let's find the inverse of this matrix here. We need the determinant to find the inverse. So let's calculate the determinant. 5 times 2 is 10. 3 times 3 is 9, and remember we subtract those and we get 1. And we use the determinant by putting 1 over the determinant and then multiplying it by that scrambled up matrix that we talked about in 12-3. We switch 5 and 2, the positions of 5 and 2, and then we change the sign of these two numbers, so it's a -3 and a -3. And then we multiply by our scalar in front. And since our scalar in front is 1, we get 2, -3, -3, 5. That is our inverse matrix. So when we multiply our inverse matrix by this matrix, we get the identity matrix. They effectively go away. So let's go ahead and write it anyways. 2, -3, -3, 5. Then we'll go ahead and write this side, 5, 3, 3, 2 times our unknown matrix. Now because matrix multiplication is not commutative, it does matter which side of this matrix here that we multiply by our inverse matrix. Remember, since we multiplied our left side by our inverse matrix, we have to multiply our right side by our inverse matrix, or this equation is no longer balanced. You will always put your inverse matrix on the left side of the matrix here. Always, 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 never on the right side. If you multiply it on the right side, you get the wrong answer. So because these two matrices, when you multiply them, that will give us our identity matrix. They pretty much just cancel out. So let's go ahead and do this matrix multiplication on this side. We get a 1 and a -3. And when we multiply these two, 1 times 2 is 2. -3 times -3 is 9. We add those. 1 times -3 is -3. -3 times 5 is -15. We add those. And we get the matrix 11 and -18. So how can we check to see if our answer is correct? What we're going to do is we're going to plug this matrix, our answer in for x. X equals this matrix right here. We're going to plug it back into our equation and check to make sure that we get this matrix on the right hand side. So we're going to lay the 11 and the -18 on top. We get 55. 3 times -18 is a -54. And then we get 3 times 11 is 33. -18 times 2 is a -36. And when we're done, we get 1, -3. So x equals this matrix right here. So what I'd like you to do is I'd like you to try an example right here. Your answer for x should equal -8, 9.